show you how to crash and wet sieve ion change resin. So on my bench, I have a bottle of ion change resin, and I have empty, clean, high density polyethylene bottle, 1 liter version, and this is a 1 gallon waste bottle for me to store the waste. And this is a DI water. And here is a glass tube with DI water inside of it. I'm going to use it to store the crushed ion change resin. And I have 2 funnels to help me wet sieving. Okay, and then here's the 2 tools. And I have 2 different sieves. One is number 200, one is number 230. And here is my mortar and pestle. Okay. So the first thing I need to do is I'm going to scoop a little bit of ion change resin in here. Then we'll add a little bit of water. It's too complicated to see. And here it will look like this. So then I will start crash. So normally I would do this to hold my sleeve. So after crashing a while, and you will see the sample become cloudy, and then we can start to sieve it. So okay, so I'm going to put a little bit more DI water to it, and then wash out all the resin, the crushed resin. Okay, so it will be a pour of resin in DI water. And then I will take out my 1 liter clean HDPE bottle. And then I can put my funnel on the top of it. And then I will first sieve the resin through a 200 US mesh sieve. I'll put it like that. Okay, then I will pour this solution through that sieve. Then anything that have a particle size less than 200 US mesh will be in this 1 liter bottle, and anything that is larger than that size will be on the top of the sieve. And then I will use DI water to squish it to wash out all the particle size that have particle size less than 200 US mesh. So wash it a few times. Okay. And then okay, I normally will find another bottle. So I have So I have another beakers, not beaker, like this container to be at here to help me to hold this set up so anything of it does not touch the table or the ground. So they can be sitting right here. And here you can see the liquid inside of the bottle is cloudy and in like a white color. Those are just unchanged resin in D.R.U water. So I'm going to filter them again through a 230 US mesh sieve. Okay, so now I'm pulling out my waste bottle. This is for the waste, for anything that has a particle size less than 230 US size. So again, I'm putting another funnel on the top of it. I'm putting this sieve on the top of it, and then I pour it through. And then see the white particle on top of it is a particle that have a particle size between 200 and 230 US mesh size. And I'm going to flush it to wash out all the fine particles. So after wash it a few times, then I feel comfortable that I have washed most of the fine particles out. I will scoop those resins, the resins with right particle size, into this small container. So, and I use this very small. Okay, so here it is. See? This is how we wet sieve, how we crush and wet sieve our unchanged resin. So and then after you have scooped out all the unchanged resin on the top of this sieve, then you start to crush again. So you will take this 200 US mesh sieve back and use a big scooper and then scoop them back. You add more D.R.U water, then you continuously crush. And once you crush a little bit more, you keep doing the sieving and connecting the sieved unchanged resin. And that's how you do crush and sieving. So now I'm going to talk about how we dry our unchanged resin. So we don't want to dry the unchanged resin in oven, because oven is in a very high temperature, and we're worried that maybe in high temperature the structure of unchanged resin is going to change. Therefore, we dry our unchanged resin in vacuum designator in room temperature. Before we dry this, we first need to remove all the supernatant water from this glass vial, so that can help us to minimize the drying time. So I will use a pipette to just pipette out all the DI water from the supernatant. So when you are very close to the surface of your anion resin, I will stop. Then we can go to the other room and I will show you how we use a vacuum desiccator. Hi! So here is our vacuum desiccator, and this is just like a normal desiccator, and on the bottom we have a vacuum pump that is pulling air from this desiccator constantly. So to dry our anion resins, we will just open this cap and put the vial into that desiccator, and it will normally take 1 to 2 days, 2 to 3 days for it to completely dry out. And at the end of when we see it looks like it completely dry out, we will continuously measure the weight of our anion resin to make sure it reaches a constant weight. And here is a dry anion resin that have been dried using the vacuum pump, or using the vacuum desiccator. The reason why vacuum desiccator, the benefit of using a vacuum desiccator is that it can evaporate the water quickly in room temperature, and under the vacuum the water is evaporated very fast. And also you can use this desiccator bag to help you accelerate the evaporation process. Okay. So in this section of video, I'm going to show you how I pack my anion resin bag. So here is my RSCT setup. I have a HPLC pump that pumps the water through my RSCTs. And here I'm building an upflow mode RSCT. So the water will be flowed from the bottom of the column to the top of the column, and then go into my waste funnel and go into my waste cavity. But for RSCT, since it's a fixed bed column, the upflow and downflow really shouldn't matter, because I'm not changing, the particle size is uniform through the column. And the first step of packing a column is I will fill my column with DI water, and also I will prepare wetted glass wool. So basically I'm just taking a little bit of glass wool and soak them in DI water. And now I can take, so the anion resin bed will go into this part of my RSCT column. So I'm going to take this column out for me to fill the anion resin. So the very important part of filling of packing an RSCT bed is you need to make sure you don't introduce any gas bubble into your column. So you need to make sure the whole process is being doing within the water, under the water. So I'm going to. So see here, there is a small air bubble here. I'm going to add a little bit more water to purge out the gas until there is a ball. And then I'm going to close this side using a paraffin. will disconnect this side. So now is a tubing full of DI water. So I'm going to put it up here for now. And now I will take a little bit of glass wool out. I will soak them in water again. Make sure they are full of water. They're saturated with water. And then I'm going to shake them a little bit. So when there is water here, and here my glass wool is also full of water, so I just put it in. Now make sure there's no gas bubble being introduced into the column. And when I push, it should be super easy to push it in. And when at the end, when it's getting a little hotter, I start to have this little stainless tool that's helping me to poke them in. Yeah. Here, the glass was in the column, but it's not ready yet. We need to put the glass wool into the correct place, and we also need to tap it a little bit to make sure the top part of the glass wool is flat enough to be able to hold the ion change resin. And when I push it very gently. I make sure I don't overpack my column. If you overpack your column with glass wool, then you're probably gonna see pressure issue during the run. And I think it's like a little bit too low for me, so I'm going to add a little bit more glass wool so the bottom of glass wool is higher than this. And when you first introduce glass wool into it, you might lose some of the water on the top. Before I pack more glass wool into it, I will add more water. Okay, this is a bad example. If you put too much glass wool at a, if the diameter of your glass wool you put in is too wide, it will be very difficult for you to push in. And once you need to put extra force to poke it in, it's very likely you will overpack your glass. So because when I try to poke it in, I feel the resistance, so I don't like it. I will take it out and do it again, and I will just dispose that glass. Basically, you can easily, gently, slide it in. See? I don't even put lots of pressure, and it can already slide in very easily. And then when I feel the resistance of it reaching the bottom, I don't push it to compact it. I do it like a gentle tap. Be very patient and gentle and tap it, and then you will get a very flat surface there. So now it's a very flat surface. Okay, so now I will, and I'm not done. So now you get a packed glass wood with a very flat top, but we are not done yet. You need to test to make sure that you didn't overpack your glass wood. How I normally do it is that I will fill it with more D.R.U water to the top. And then I will hold the top with my finger, and then I will open the bottom. And I will have a waste beaker holding on the bottom, and I want to make sure the water can flow through the column freely without any does not feel like the glass wool is stopped your flow. So see, if I release my hand, then see, the water is flowing down very fast. So that means you didn't overpack your flow. If you overpacked your flow, you will see the water flowing down super slow. Yeah, and then you can, but you just need to be careful that you don't want any air bubble in your glass wool. So you either hold your top or hold your bottom. Don't ever let the water level go below your glass wool. Do that, and I'm going to fill more water. Test it again. See, it can freely flow down. And now I'm going to fill, so I know that my glass wool's good, and I will fill the tube until the top, and then okay, I'm going to put another paraffin here to hold one end of the column for me, so I don't need to hold it all the time with my hand. So it's not flowing right now. I'll put it here. So I'm going to get one of the valves and connect it at the bottom of this part. So then I can control the flow rate of the liquid. You can see this is our glass wool, this is the D.R.U water in there, and we have a valve here, so we can close the valve and just remove the paraffin on the top. That's fine. You can try testing the flow rate again, and then we can close it when we want. So now we are ready to pack our anion resin or any other sorbent into your column. Here as a demonstration, I have this re-wetted anion resin in a small glass vial. I also have this for, this is a GAC in D.R.U water in a small glass vial. So today we are going to pack an anion resin column. It will take a pretty long time, so it's better to find a chair. And then, so to transfer the ion change resin into the column, we will be needing a glass pipette. And then we first need to free up some space in the column. So we open this valve, but never let the water level go below your glass wool bag. So I will just look at it until it's full to get here. It's like maybe 1-2 centimeter above your glass wool bed. That's good enough. And then you close the valve so the water won't flow down. And then I will start to open this tube and then start to transfer using this glass pipette. And then after I fill it to the top, I'm going to open this valve. Always make sure that your water level does not go below your bed. And see, because the water is being filtered out through the glass wool, and then your ion change resin is being left on the top of glass wool, and now it forms a natural ion change resin bed there. So just continuing doing that step until you have transferred all your ion change resin from this glass vial into that column. And as you start to pack your column, the flow rate is going to be slower and slower, and that's normal. As long as you are not overpacking your glass wool, you're fine. So after you have transferred all of your resin into the column, this is how it looks. So here, the bottom is your glass wool, the middle part is your ion change resin, and just be careful that note that at the bottom of the ion change resin bed, it should be very, very flat, and on the top of ion change resin bed, it should also be very flat. So, and now we're ready to pack glass wool on the top of your column. So to do that, I normally prefer to add a little bit of a glass wool on the top of the bed first, because if it's a very small amount of glass wool, it is easier for me to shape it to make sure the top of my ancient resin bed is flat. So to do that, first you need to fill your column up with D.R.U water and form a little ball on the top. You see here is a water ball. And then I will take a little bit of glass wool out. Just like that much. And then I dip them in water again to make sure they are all wet. Look like this. And then I put it on the top of my column. And then I just poke it in. So just a little bit, see? And because it's very small amount of glass wool, it's very soft and it's easy to shape it. So just poke it all the way down. And do it gently, pack it. Like super gentle. So you don't compress your bed and you don't mess up with the top layer of your ancient resin. That's it. And then I will add more. Still the same. Don't overpack your glass wool. If you feel like this part is very wide or there's too much on this side, and then you just take some off. And you feel it's like slim. And then you soak them in water again. And then before you pack your glass wool into it, you find a clean pipette and add the water until it forms a ball on the top. It should be super easy to slide it in. And that's it. Now it's packed well, and you're ready to assemble it back to your sampling line. Now your exchange resin bed is ready, so we want to put it back to our whole RSSCT setup and connect it with the HPLC pump. So the first thing we want to do, because we don't want any bubbles in the system, so the first thing we want to do is make sure that all this sand is filled with water and you have a water ball here. So I'm going to turn on the pump until there is a water ball, and then make sure there's no gas anywhere. And stop it. Actually, the first thing that I'm going to do is connect the top part, which is this part. So now I have these two valves closed, then the pressure won't allow the water to fall out. And then I can disconnect it. And then I will wipe out all the water. Make sure there is a water ball adhered to, so when I connect them, I won't introduce any gas bubble into it. I'm going to open this valve and then open. I'm going to open it a little bit. Now you can see at the bottom there is a water ball, and on this side I make sure there is a water ball as well. And then I connect them. Part is turn on, this part is turn on, and then you can turn on the pump. So you see your bed is not moving. And make sure there's no leaking from anywhere. And that's how you build an RSSCT column with unchanged resin. So after you pack your column, it's very important to check that you don't have any air bubble or gas bubble inside of your column. So just like this one.